We're going to solve this problem, y double prime minus y prime minus 12y equals 2x cubed minus 1, using the method of undetermined coefficients. So in here, we're just looking for the particular solution. Let's go ahead and do that. So this is a third-degree polynomial. This is a second-order constant coefficient linear ordinary differential equation. We can plausibly guess the particular solution. So we're going to have y particular is equal to a third-degree polynomial, because this is a third-degree polynomial on the right. So we have a x cubed plus capital B x squared plus c x plus d, excuse me. Right, then take two derivatives here, so y particular prime of x is 3x squared plus 2bx plus c, and y particular double prime of x is equal to, let's see, 6, and I forgot the a here, sorry about that, 3ax squared, so this is 6ax plus 2b. And then we're going to plug this into the differential equation. So we've got y particular double prime minus y particular prime minus 12y particular, and we want to expand that out and figure out what it equals. So to do that, okay, y particular, I can write that down. It's 6ax plus 2b. All right, then I have minus y particular prime. So minus, I've got 3ax squared plus 2bx plus c, and then I've got minus 12 times y particular, which was ax cubed plus bx squared plus cx plus d. Right, now we want to try and split up all these terms into their different, we want to group all the x cubes together, all the x squareds, all the x's, and all the constants. So if we do that, we only have one cube term. We have negative 12 times a times x cubed. We've got negative 12 ax cubed. For the squared terms, let's see, I'll do a plus. I think there's going to be two of them, so I'll just do that. There's a negative 3ax squared, so negative 3a, and there's also a minus 12bx squared, so minus 12b. So that's all the x squared terms. Now I want to worry about the x terms. There should be three of those. So there's a 6ax, 6a. There's a negative 2bx, so minus 2b. And there's a minus 12cx, so minus 12c. And then we have the constant terms, so that's going to be plus. I've got this 2 times b. And then I've got minus c. Yeah. And then I've got minus 12d. Oops, d. And now the thing we have to do is we have to get that to equal 2x cubed minus 1. So it looks kind of nasty, but you can actually go through kind of step by step here. So I have 2x cubed, and that has to equal negative 12a x cubed. And so if you take 2 divided by negative 12, you end up with a is equal to negative 1/6. All right, so next up then we're going to have here, if I plug in negative 1/6, I'll get, let's see, negative 3 times negative 1/6, that's actually positive 1/2 minus 12b, and that actually has to equal 0. So on this side I could have written, 2x cubed plus 0x squared plus 0x minus 1. Right, I have to get my x squareds on the right-hand side to match my x squareds on the left-hand side, so I have to have 1/2 minus 12b is 0. So if you solve for b there, b ends up equaling positive 124. I'm having to use my notes here. I can't do fractions that fast in my head, but you solve for b. All right, so now we've got capital A, we've got capital B. Now we move on to the x terms. So I want to plug in the value I had for a. So I have 6a times negative 1/6. Well, that's just going to be negative 1. I have minus 2b, and so I have this negative 2 times 1 over 24, that's minus 1/12, and then I have a minus 12c. And that also has to equal 0, because there are 0 x's on the right-hand side in the g of x. So that one is going to be pretty nasty, but if you do, combine the negative 1 and the negative 1/12, you move it to the right-hand side, you divide by 12, you end up with c equals negative 13 over 144. So these do get a little nasty. All right, so now we move on. We want to figure out what d is. That's the last one that's remaining. I'm going to draw a little squiggly line there to separate them. Here, let's do that for all of them. All right, so now I have 2b minus c minus 12d has to equal negative 1. So then 2 times b, okay, so 2 times 1 over 24, that's a 12. Got minus c, okay, minus negative, so plus 13 over 144. Then I have minus 12d. And that has to equal, here I'll do a squiggly line, equals negative 1. And so if you end up solving for d, you get a truly horrible number. You get d is equal to 169 over 1,728. So if you go through and you do all the math and all the lovely, lovely fractions, the y particular solution that actually solves for the right-hand side of the differential equation is going to be, let's see, we've got negative x cubed over 6, right, negative 1/6 from the a. Then I've got a plus x squared over 24. Then I've got a minus 13x over 144. And then I've got a plus 169 over 1,728. And so there you have it. This is solving for the undetermined coefficients. We figured them out. So if you plug this into the differential equation, do all the math, add everything together, you will end up simplifying the left-hand side to 2x cubed minus 1.